So we have been doing ray tracing in our past videos, and we've been dealing exclusively with our good friend, the concave lens. And there's one concave lens. There's another concave lens for you right there. I'm sorry, mirror, concave mirror. Lenses will be next chapter. And so we had ray tracing simplified, and we have a concave mirror, optical axis, trace the rays of light. You can watch that video. We had the object distance is greater than 2 times the focal length. And then we did the object distance was between 1 time the focal length and 2 times the focal length. And so not all that surprising right now. We're going to do object distance is less than the focal length. And we're going to still have, but now we're going to sort of change things around a little bit. I'm going to put the mirror right there for reasons that are going to become clear in a second. So let me just check that that's going to work. Hopefully that's going to just work out okay. And I'm going to put the optical axis down here. So this is my concave mirror. And this is my optical axis. And I'm going to have a focus of, we'll call it 6. 1, 2, 3, 4, 5, 6. So my focus is 6 centimeters. And we're going to put a little dude with a light on their head. That is going to be 4 centimeters. Alright, so I'm going to continue with my regular old ray tracing. I'm going to go in parallel, and I'm going to go out through the focus. Probably missed that a little bit. I'm going to try to redraw it a little bit. And then I'm going to go in through the center of my lens. I'm sorry, we're still working with mirrors. So in through the center of my mirror, and then it's going to go out at the same angle. So if I went up 3 boxes, I'm going to go down 3 boxes. So I'm going to come out like this. And some of you guys are going to notice that I punted on this. I punted on one of them. I actually punted on the first one. The first one was, well, actually the second one. The second one that I was normally doing, here I said, okay, it goes through the focus and out parallel. Through the focus and out parallel. Now, since I'm inside of the focus, something strange happens. What I need to do is I need to identify what that line from the focus to the top of my object is. So it's going to be like this. So there's the line from the top, from the light on the guy's head to the focus. But what the light is going to do is the light is actually not going to actually pass through the actual focus. It's just going to go along that line. So the light is actually going to go up this way until it hits the mirror, and then it is then going to go out parallel. So now we encounter our next little spot of bother, and our next difficulty is that these three lines do not meet. So these rays of light will not converge any place. They will never meet. So it will not create a real image, and we're going to have to talk about real images and virtual images in a second. But right now we've got a virtual image because the question is, we have to say, where would these have met if they all came from one spot? So what we have to do is we have to back them up. Where they did meet, where they might have met in some other universe, is somewhere back here. So I take these and I back them up. And what I say is these three rays of light look as if they could have come from this image back here. And so this is my virtual image. It's not a real image because the rays of light do not actually really meet for real. They kind of meet, it's kind of as if they could have met back here. And so then once again I do 1 over I is equal to 1 over F minus 1 over O, and so I get 1 over 6 minus 1 over 4, and so that's going to give me I is equal to 1 divided by 6 minus 1 divided by 4. I flip that. I'm going to get negative 12. We have not gotten a negative yet. We have not gotten a negative yet, and the negative means that it is behind the mirror. It's on the wrong side of the mirror. So if I count back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there is my image at negative 12. So when we are inside the focal length, we're going to get a negative, image, which means it's going to be a virtual image, and it's also going to be upright. So we're going to come up with some rules. In the next video I'm going to discuss some rules for concave lenses and also magnification.